What's up, all my fifth grade peeps? Hey guys, Miss Sarah Lambo here. This week for our review remediation, we're talking about physical and chemical changes. So we're talking about last week with mixtures and solutions. We're kind of digging deeper into that and talking about things that can create physical or chemical changes. So let's jump right into it. We're doing SC5 P endpoint 1. P talking about those physical properties. So here we go.
I love marshmallows.
What? Don't talk with your mouth full, Mia.
Sorry, I said I love marshmallows.
Oh, me too. But you know what I love even more? S'mores. I brought chocolate and graham crackers so we can make some.
Yeah, RJ. Hey, what's up? Something wrong?
These crackers are all broken into pieces. Look.
No worries. It's just a physical change.
What do you mean physical change?
Physical change is just when the size, shape, or state of matter changes. See, the cracker is broken, so its shape is different, but the pieces are still graham crackers. We can use them.
Yeah, I know. It just stinks that they broke. I don't know how it happened.
Well, physical changes like this happen a few different ways. Motion, pressure, or even temperature could have made the crackers break.
I guess I was a little rough with my backpack when you were in there. Maybe I shouldn't have thrown it around.
Probably not. Throwing the crackers around is probably exactly why they're broken now. But as small as the pieces are, they are still graham crackers, and their molecules haven't changed.
Well, there's no way I could change their molecules. How would I do that?
There are ways. When the molecules of matter change, it's called a chemical change. Chemical changes usually can't be reversed like physical changes can. When the molecules change, the matter turns into something totally different, like the logs in our fire.
But the logs are still logs.
They are, but not for long. The extreme heat of the fire is causing a chemical change that turns the logs from wood to ash.
Huh. Yeah, I see some ash at the bottom of the fire. I guess I didn't realize it used to be the logs. How can you tell that it's a chemical change?
There are clues. If gas forms, if light or heat appears when the change takes place, or something changes colors. You know, like when you see a penny that looks green, or rust at the bottom of an old car.
Oh, yeah, I've seen that. So I guess it's good that I didn't drop the box of crackers in the fire, huh?
That would have meant no s'mores for us. If the crackers had been burned, we wouldn't have been able to turn them back into crackers. We probably wouldn't even be able to tell they were crackers to begin with. So really, broken crackers, not so bad.
And burnt crackers? No good.
You got it.
Okay, I think I understand the difference between a physical and chemical change now. Breaking the crackers was just a physical change because only the form of the crackers was changed. Temperature, pressure, or motion, like me throwing my bag around, can cause physical change. A chemical change changes the molecules in matter, and that can't usually be reversed. A physical change can be reversed most of the time.
That's dumb.
I'm just gonna pretend I understood that and say thank you.
The really cool thing about Study Jams, guys, you can always type in studyjams.com and it'll pop up exactly to the screen, and you can type in what content you want to learn on. So for example, this would be physical and chemical changes, and then you would be able to learn exactly this. If you ever want to dig deeper into something of your own, you guys have learned, used Study Jam before. And then there's also that test yourself. So just giving you guys a heads up if you ever want to use that to your advantage. All right, so here we go. Changes in matter. So we're talking about that SC5P endpoint 1. Remember, this is a review, a remediation. So everything you have definitely heard of before, but this is just to dig a little bit deeper. So how can physical and chemical changes be affected by temperature? So physical change, you physically change it. So physically changes occur when a material changes its physical properties, such as its shape, but not its substance. So if I'm cutting paper, the paper is going to be a different shape than what it began as. However, the paper I cut off and the paper that is still there is still, you guessed it, paper, right? So I'm not changing the actual material. I'm changing the size or the shape of it. And if I wanted to, I could take tape and put it back together. So what are some other ways to physically change this paper? We'll actually talk about this. So tell me some ways how I could change this paper. I could fold it. I could make a paper airplane. What about if I burned it? Would that physically change it? Right, it would completely change it. It would no longer be paper, it would be ashes. So there's the difference there. Physically meaning I'm just changing the size or the shape. So here we go. Physical changes and then changes of states. Changing from one state of matter to another is called a change of state. Changes of state are caused by changes in temperature. Temperature can speed up the change that is called the rate of change. When liquid water is heated, it becomes water vapor. Think about your mac and cheese. When it's cooled back down, it turns into water or a liquid. When it's put into the freezer, what does it do? It freezes. It becomes a solid and turns into ice. So changing the temperature is going to change the actual state. It starts off as a liquid, or it could start off as an ice cube, or it could start off as a gas. If I take a gas full of air and I put it into a cold area, right? Or if I take that balloon and I put it into a hot area, what's going to happen? So that's something that you might be able to do on Friday, the next time we meet, or Wednesday even. Which of these conditions has the greatest effect on how quickly a substance changes from one state to another? We just talked about this. Is it the color of the object, the light, the shape, or the temperature? What do you guys think? Yeah, D or I or D. I, temperature, right? Definitely the temperature as to how things are, whether they're heated or cooled down. Number 2, Miss Tyler left some candles burning. After a while, the heat from the candles made the wax begin to drip, which describes the change that happened to the wax. So my wax began to drip. So did my wax change? Its shape, its size? Is it still wax, or did it become something different? A, a physical change. It formed from a solid to a gas. B, a chemical change from a solid to a gas. C, a physical change from a solid to a liquid. Or D, a chemical change from a solid to a liquid. So we know we can eliminate 2 answers. Which 2? Right. B and D. We have not talked about chemical change yet. So we know it's either A or C. So we know it's a physical change. So what did it change from? If you have a candle, is that a solid, a liquid, or a gas? Yes, absolutely a solid. And then it says, uses the word start to drip. So what would drip be? It's no longer a solid. It's turning into a, you guessed it, a liquid. So the correct answer is C as in cat. Physical change from a solid to a liquid. Great job. All right, guys, chemical changes. So chemical changes occur when one type of substance is changed into something completely new. There are many chemical changes that take place around us every day. So one big one is rust. No matter what, I cannot take rust off of something. I can stop it from happening more. I can, what's it called? I can rub it down to its new form, but that rust is going to continue to come back. What about my apple down here, right? I don't want to eat that rotten apple, and I can't bring it back to its original form. An egg. Once I crack that egg, I cannot take that egg and put it back into its shell. It's completely changed. A match. Whenever there is fire, it's going to create those ashes, and I can't turn it back into what it once was. So I can no longer use that match again. The way that I think about this, guys, is if something is completely changed, I cannot take it back to Walmart. I cannot take it back to Wally World. If I take back a cooked egg to Walmart and I say, I didn't like my eggs, can you return these? and they open it and all of my eggs are cooked inside, they might look at you a little crazy, right? So talking about if it's completely changing. So what are some signs of a chemical change? It smells different. The best example of this is a fire. It's going to smell. Have you ever lit your hair on fire or grass on fire or wood on fire? It has a distinct odor to it. A change in color. If it changes from one thing to another. Think about your bicycle. If you leave it out in the rain, rust is going to form on it after a while. It's going to change color. A change in taste. Yeah, talking about that rotten apple. I do not want to eat that rotten apple. It's going to taste completely different. If it forms bubbles or gives off a gas, if it changes in mass. So think about a piece of paper. If I burn that piece of paper, is it going to weigh the same? No, those ashes are not going to weigh as much as that piece of paper. Giving off smoke or giving off light. So burning. Burning is a chemical change. When a piece of paper burns, the paper and the oxygen in the air combine to form ash and carbon dioxide. Burning a candle changes the wax and the wick into soot and ash and gases. Now, you're talking about a candle. I cannot take it and put it all the way back together, right? Now, in the first question, it was talking about the wax. Now, this is actually talking about the candle aspect of it. I cannot take the wick and put it back together. Now, the wax itself is still wax, right? And all I did was change the shape and the size of it. But now it's talking about the whole candle and the wick. I cannot put the wick back inside and re-burn the candle. Decay. This is talking about your fruits, your plants, anything that may die. So decay is an example of a chemical change because it changes the material of an organism's body into new things. You would not want to eat a decaying strawberry, a decaying apple. It's not going to taste the same. It's going to taste disgusting because it essentially died, right? So thinking about the word decay, died, DD, right? Things in common. So cooking. During the process of cooking, materials often change into other materials with different characteristics. Here's that egg again. Once it is cracked out of that shell, right? I can cook it. I can hard boil it. I can cook it on the stove, but it is no longer an uncooked egg. I cannot return it to Walmart. Same thing over here with a pancake. You have to use their pancake mix, milk or water, mix it together. Once I cook that pancake, I cannot take it back to Walmart. I cannot say my pancake mix did not taste right and take them back a pancake. Well, let's be honest, right? Rust. Rust is an example here in the picture. We talked about our bicycle rusting, leaving it out in the rain. I cannot take that bicycle and return it to Walmart. They would look at you like you were crazy, right? Here's my bike. It's covered in rust. Yeah, guys, it is not what it once was, right? And it changed in color for sure. The process of rusting is a chemical change that can affect metals, rocks, and soils that contain iron. So let's go. Here we go. Time to explore. So what I want you to do is basically just tell me out loud whether it's a physical or a chemical change. We will definitely be going over this on Wednesday. So example of changes: water boiling into steam. P or C? Ice cream melting. A bicycle rusting in the rain. A banana turning brown. Tearing paper into pieces. A candle wick burning. Water freezing into ice. A carton of milk going sour, a loaf of bread cutting into slices, or D, burning toast in a toaster. So once again, I want you guys just to number 1 through 10. You can keep this for when we meet back up and talk about this live, because I don't want to give you any of the answers yet. All right, guys, here we go. Jacob put yeast into a bowl of water and added a little sugar. He put the bowl in a warm place. After a while, Jacob observed foam spilling out of the bowl. What kind of change is occurring? A, physical, B, chemical, C, scientific, or D, geological? Which two can we automatically get rid of because we have never once talked about them? Right, C and D. They just throw those in there to confuse you. So now is it a physical or a chemical change? If foam is spilling out of the bowl, then that means that there is a gas that occurred. So the best answer is B, chemical change. Number 2, why does milk have to be kept in the refrigerator? A, milk tastes better when it's cold. B, the reactions that cause milk to spoil are slower at lower temperatures. C, physical changes that cause milk to spoil are slower at lower temperatures. Or D, no chemical or physical change can occur at cool temperatures. So even if that milk is in the fridge, after it goes past its expiration date, you will still start to see it go sour. So why do you think it's best to keep it in the fridge? Good. B, the reactions that cause milk to spoil are slower at lower temperatures. If I were to take that milk and put it outside, it would spoil way quicker. Last one, which of the following represents a chemical change? So something I cannot take back, something that I cannot fix. A, broken glass. B, fireworks. C, a water dam. Or D, cutting wood. Which one could I not take back to Walmart? Which one could I not put back to where it first came from or back to its original state? Good. B, fireworks. Yes, I cannot take those fireworks and put them back into the tube and return them to Walmart. A, I can take that broken glass and say, hey, I can take that glass and I can put it back to glass. That broken glass is still glass. It didn't turn into water. It didn't turn into anything. It's still glass. C, that water's still water. And D, the wood is still wood. I just made it smaller or cut it into pieces. All right, guys. You rock. You rock. You're real quick while I'm still sharing here with you guys, I'm going to go ahead and show you what's going on for this week. Here is our outline. I'm going to insert our YouTube video here. Here's the pages for JJ Bootcamp. Moving on, we have our text dependent. I will put this in the same platform on OneNote so that you can use it and type right into it. We meet Wednesday and Friday at 9 a.m. Wednesday and Friday at 9 a.m. On Wednesday when we meet, I will talk about our assignment. However, if you want to get ahead of the game, here is our assignment. You will draw and explain a physical and a chemical change. Right? All right, guys. You have been awesome. I will see you live. Until then, be awesome, do awesome, and I'll see you soon. Bye, guys.